2.5-axis milling. 2.5-axis milling includes automatic roughing, finishing, thread milling, as well as single-point cycles such as drilling, boring, reaming, and tapping to machine prismatic features. These cutting cycles provide fast, error-free toolpaths using ball, flat-end mill, taper, corner round, thread mill, and hognose tools. Let's look at some options and settings you can use to produce accurate, high-quality toolpath. Avoid areas can be used as a definition for clamps and other areas that are to be avoided. Contain areas can be used to define a specific region within a feature for machining. For example, a contain area can be defined for corner cleanup or to machine areas that were not machined due to clamps or fixtures. Depending on the tool diameter you're using and the feature you're machining, the tool may need to retract and re-enter the feature in another area to avoid gouging the part. When this is the case, CAMWorks provides options to machine all areas at a given Z depth before machining the next Z depth, or to machine to the full depth of each area before machining other areas. With the option to generate an entry drill operation automatically for rough and finish operations, CAMWorks will select a drill based on the parameters defined in the technology database. This avoids the possibility of the drill tool gouging the part when piercing on the side of a feature. Plunge roughing allows you to rough machine deep cavities by making a series of overlapping plunges into the material following a zigzag pattern. This option provides a fast and efficient method for removing large amounts of material or very hard materials. Although a rough mill operation can generate toolpaths that will remove material from a face feature, the face mill operation provides specific controls to produce toolpath motion that is more appropriate for this task. This operation can produce a single cut across the top of the part when the tool diameter is larger than the width of the feature being machined. In CAMWorks, you can either machine an entire feature, calculate toolpath from work in process, or from previous leftover or roughing operations. CAMWorks can generate and graphically display the theoretical areas of a feature not machined by the rough cut. When the rough toolpath is calculated from work in process, it is based on both the feature shape and the current stock shape. When the toolpath is calculated from previous leftover, it is based on the feature shape and the theoretical leftover areas. CAMWorks provides toolpath optimization that allows you to minimize tool travel from toolpath to toolpath, whether using a grid or shortest path method. This is especially helpful in cases when machining multiple features, either as a pattern or individual features. Toolpaths for whole and non-whole features can also be optimized.